Okay, this warm-up right here, hopefully you've done it already. If you haven't done it already, again, this is an opportunity for you to practice, and I'm going to show you the answers. So I would recommend that you pause the video, attempt the problem on your own, and then come back and look at the answer. This particular warm-up asks you to find the conditional distributions of plans for the minority students and find the plans for the white students. So you are conditioning it on gender, okay? So you are going to find the total of this column, find the total of this column, and then find your percentages. Once you do that, you have your choice of the different kind of graphs you can make. We kind of saw this yesterday at the end of the notes. So I'm going to show you the answer that I have right now. So again, added up the totals there, and I took the 198 divided by the 268, the 44 divided by the 57, and I filled those out. I made the graph here in Excel. You can kind of see here my differences. You can do a side by side. As far as some comments here, so really their plans look very similar. For each of them, the majority of them are going to a four-year college. The minority of them are going into military. There are slightly more minorities going to a four-year college than there are whites. There's slightly more whites going to a two-year college than there are minorities. But there's really not too much difference going on here. Okay, here's another opportunity. Again, if we are in the classroom, I usually have you guys stop, talk about this with your neighbor, and think about what you think you should do here. So Brian and Jessica have decided to move and are considering 7 different cities. The dot plot showed the daily high temperatures in June, July, and August for each of these 3 cities. Help them pick a city by answering the questions below. So again, this right here, these are the different cities. And here's the temperatures. It's not a very good graph. There's no labels on it. And you want to look at the different graphs there and then answer the questions below. So again, take a minute, pause it, go ahead and think about that. All right, if you did your pre-reading, you are familiar with the acronym SOX. So that's kind of what this is getting at right here. So if you look at number 1, it says, what's the most important difference between cities A, B, and C? So the biggest difference here between cities A, B, and C is where they are centered. So their centers are really the biggest difference here. So the middle of these distributions, A has the highest center. B has the lowest center. So this A is going to have higher temperatures in the summer than B is going to have. Okay. What's the most important difference between city C and D? So if I look at this one right here, so C is contained, D is more spread out. So the spread is what I'm seeing is different here. All right, so again, it doesn't necessarily mean one's better than the other one. It just means that they're different spread out. So this one's spread out. This one's going to have a lot more like consistency in the temperature. This one, you're just going to get some more extremes there. What's the difference between D and E? So the spread is the same here, but if you notice here, the only reason why the spread's the same is because we have those 2 outliers. If we didn't have those 2 outliers, the spreads would not be the same at all. But since we have those outliers, that's throwing off things, all right? So with that particular one, we'd say the outliers are different. So for the most part, you have pretty consistent days, but then you have these really weird off days. And then what's the most important difference between C, F, and G? So C is more symmetric. F is skewed. The tail is over here, so it's skewed to the right. G is skewed, the tail is over here, so it's skewed to the left. Their shapes are different. So again, there's your SOX right there. So your shape, outliers, center, and spread. So now, as far as which city should they pick, I can't say, there's obviously you could pick whatever you like. Do you like warmer temperatures? Do you want some more consistency? Do you want things to be spread out? Do you want maybe you want warm temperatures, but some cool days. So it just kind of depends. The idea here is that just knowing one of these metrics isn't enough. It's really helpful to understand our distribution. Remember, distribution is the values the variable takes, that pattern there. So it's really ideal to kind of know all these things to get an idea of what's going on. All right, when we do quantitative data, so now we're doing quantitative, this is numbers. We're not talking about doing categoricals. So categorical we did yesterday. We had our pie graphs. We had our bar charts. They're segmented. So now we want to look at some different graphs here. So if we were in class, I usually try to collect some data, and I usually try to collect your height. We're not in class, so I'm going to just go through this example here in the book real quick. All right, so how to make a dot plot. So when we're making a dot plot here, right here, in this one right here, we have how good was the 2004 U.S. women's soccer team. So they've got all these teams here. Here's the number of goals scored by the team in 34 games played during the 2004 season. So when I'm making that dot plot, what I want to do is I want to draw a horizontal axis, which is essentially a number line. So I'm drawing that horizontal axis and I'm drawing that number line. When I want to label that number line with the variable name, so in this case it's number of goals scored, that's the variable, and I want to scale the axis. I'm going to scale the axis by looking at the minimum and maximum values. So in this particular data set it's 0 and 8. Okay, so I'm going to go from 0 to 8. Just like before, we want to keep that spacing consistent there, all right? You don't want to cram anything together. You're trying to see the shape here. If you don't keep that spacing consistent, you're going to throw off your graph there, your shape. Okay, so you're going to mark the scale there. And then you mark a dot above the location corresponding to each data value. So as an example, I've got a 3 here. So that's the first dot. I've got another 3. That dot goes above it. I got a 0. That dot goes there. I've got another 3. That dot goes there. So you just keep stacking the dots if you have repetition. The other thing you want to notice here is that that height there of that first dot is the same for all of them. You're not spreading your dots out when you stack them. You're keeping that spacing, both the spacing horizontally and the spacing vertically, consistent. So if you're going to space these dots further, you want to make sure you're spacing all of them. You don't want to distort the shape, okay? All right, so when we make these graphs, it's not enough just to make the graphs. Like I said, we want to understand a little bit about it. We want to be able to describe it. In the book, you've got the socks here. Okay, so you want to describe your shape. I made the O lowercase because we only really want to describe outliers if we see them. We want to do the center, and then we want to do spread. Okay, so when we do those things, you want to make sure whenever you are asked to describe a distribution, or if you are asked to compare a distribution, or if you're asked to talk about a distribution or anything like that, you always want to make sure you get this socks here. All right. Again, the outliers, I made it a lowercase o because you don't have to describe it if you don't have any outliers. Right now we're going to kind of be more generic because we haven't really plugged anything into the calculator to find any measures of center or to find any measures of spread. So we're going to talk about things more in generic terms. Once we learn how to calculate those things, then we're going to use the actual numbers. All right, so with your symmetric, when we're describing shape here, your symmetric, it could look like a bell-shaped curve. It could be a triangle be symmetric. It could be a rectangle. Anything, when I split it in half, it looks the same on both sides. If I'm skewed to the right, you're always skewed in the direction of the tail. So that tail, wherever that tail is, that's your skew. So in this case, if I'm skewed to the left, my tail's on the left. Unimodal is just one peak. Bimodal would be 2 peaks. If ever you're referencing something as being bimodal, you want to mention either where are the peaks, or you want to mention where the gap is, okay? You can also say something is multimodal. Again, that would mean that there'd be more than 2, so there'd be 3 or more. If you're going to do that, you still want to mention where are those peaks, where are those gaps. Uniform, you want it to be flat across. So here it says describe the distribution of heights. I didn't give you that. We didn't do that problem, so we're going to describe the distribution here of the goals. Again, I'm going to talk more generically here. So I might say that the shape here is, you can also always say roughly or slightly. It doesn't have to be certain. So I'm going to say here that the shape is slightly skewed right. So the shape is slightly skewed right. The center here, so when I look at the center, I am trying to figure out, again, I don't know, I haven't calculated anything yet, so I am just kind of more going with an idea of like where the middle is. So I'd say maybe the middle is around 3 goals. There doesn't appear to be any outliers, so I'm not going to mention that there. And for the spread, for the time being, I'm just going to say that the range is just the max minus the minimum. I'm going to say the range is 8. Okay. Once we like learn how to calculate numbers, we will calculate them and use those, but right now we're not there yet. All right, so when you're asked to compare two distributions, so the same thing works. So you always want to do socks again, and you want to use comparison words. So when you're using those comparison words, you want to say higher or lower or bigger or whatever. So you just want to make sure it's clear that you're comparing the two. So go ahead and try this example here, and then I'll go over it with you. All right, so when we are ready. Okay, so in this one here, when you're comparing things, you can kind of get away without using the numbers because you're just going to say one's higher or lower. I know this is ironic here. They put the top freezers on the bottom and the bottom freezers on the top, but the bottom freezer data is right skewed. There's a tail over here, whereas the top freezer is symmetric. Again, I'm comparing them. I'm not listing them separately. The bottom freezer center is higher. So the center, again, just eyeballing where I think the middle is right now. I didn't calculate anything. So I'm thinking the center is higher versus the center of the top. I added the numbers here, but again, you don't really have to. The bottom freezer energy costs are more spread out than the top freezers. It appears that there are 2 outliers for the bottom freezers. If I read this alone, so again, I hit all my socks there because I got my shape, my center, my spread, and my outliers. If I read this alone, I would still get an idea of what's going on without actually seeing the graph. So that description should be good enough that I can get a visual there of what that graph is showing you. All right, the other kind of graph we can make besides a dot plot is we can make a stem and leaf plot. So these ones you're a little bit familiar with. Again, if we were in class, I would try to collect some data here. Since we're not, I'm going to use the example again in the book. So this one right here is about shoes. Everybody likes shoes. So it says, how many pairs of shoes does a typical teenager have? So to find out, so we got students, they're conducting a survey. They select a random sample of 20 female students, and they record the number of pairs of shoes that each report having. So they make a stem plot here. So what you want to do is you want to separate your data. So you separate them right here. We have 2 digits, so we're just going to split them right in half. So the first part is going to be the stem. The second part is going to be the leaf. So you would want to put, and if you notice here, the smallest one is 13, the largest one is 57. So your leaves, your stems are going to go from 1 to 5. You want to make sure that they're in order. What I would do next, I'd kind of skip this step right here. I would just go straight to putting the leaves in order. So for example, the ones you have right here, you have 13. I'm going to write these numbers here. So I'll do this one right here. So you have 1, 2, 3, 4, 5. So what I would try to do here, this is shoes, pairs. What I would try to do here, so I have a 13, a 13, a 13. I have 2 13s, and I have a 15 and a 19. So then a 3 13. So I would just go 3, 3, 3, 5, and 9. So you want to make sure they're in order. You don't want to leave them out of order. You just want to make sure that they're in order. And then I would go to the 2s. So with the 2s, I got 26, 26. So I've got 6, 6. I have a 4 and a 2. I have a 3. There's another 3. So it looks like I have 2. And then I have 3, 3. I have 4. And then I have 6, 6. All right, and then I would keep going there. Sometimes kids have it. I'm just going to copy the one here because I know it's done correctly. Okay, a couple things you want to notice here about what I'm trying to do. I'm trying to keep this spacing here lined up, okay? Again, I'm trying to keep this spacing here lined up. I don't want to stretch out any of these rows here. I don't want to squish any of these rows together, okay? I want to be able to see what's going on here. Other times I'll see kids try to put commas there. I don't think it's wrong, but it just kind of makes, I think, everything kind of cluttered a little bit, so I'd avoid doing that. If I want to make a key, so I'm just going to do 1/3 means 13 pairs of shoes. All right, the other thing we can do with data is we can make an expanded stem and leaf plot. So when we expand the stem and leaf plot, what we do here is we're basically expanding the stems. So I'd have the same title, I'd have the same key, but instead of having 1 1, I'm going to have 2 2s and 2 3s and 2 4s and 2 5s. And then what I'm going to do is that first line right here is going to contain the first line will contain all the numbers, all the leaves 0 through 4, and the second line will contain any leaves that are 5 through 9. So I'd have 3 3 3, and then I'd have my 5 and 9 there. I'd have 2 3 3 4, and then I'd have my 2 6s. I'd have 0 1 4, and then I'd have my 8. I'd have my 9 here. Notice here I am not writing a 0. There's nothing there. If I put a 0 there, then that's like saying I have the value 40 in my data set, and I don't. Also notice I'm not leaving it out because I want to show that there's a gap there, all right? And then I'd have 0 0, and I'd have 1 7. Okay, what I could do here, so again, I'd have the same key. That's why I kind of did that squiggly line there. All right, so a couple things here. We can describe things. So if I flip it here, the shape, I'd probably say, you know, maybe slightly right skewed. If you want to say it was symmetric, that'd be fine too. Right now, again, we're not calculating any actual numbers, so I'd say the center is around 26. I don't see any outliers, and I'd say my range goes from 50, so the range, the max is 57, the minimum is 13, so 57 minus 13 is going to give me 44, so I'd say the range is 44. Again, I don't think I'd change the shape based on looking at that. If you wanted to mention that there was a gap, that there was nothing in the 40 through 44 range, we could say that. It's not really necessary here. It's not like a huge gap. It's not like we have, but let's say we were missing, you know, all these numbers here. So if I had a gap from 24 to 49, maybe I would mention that there's a gap. There's no shoes between 24 and 49. Because that would be kind of interesting to know. That would be something unique there. All right, so we can expand the stem and leaf plot. Typically, you do see that expansion there, 0 to 4, and then 5 through 9. All right, we can also do back-to-back stem and leaf plots. So let's say here we got data for the males and data for the females. So here we have in, believe here, okay. All right, so here's our male data. So they took the male data and they put it in there. So they collected data for the males as well. So what they did here, so they've got the male data. If you notice here, they ended up splitting the stem there, which is really not necessary. You could leave them together like that and put them together, or you can split them. So this is just an expanded back-to-back, okay? You could, like I said, you could leave them together. The important thing to note here is that when you're doing this back-to-back one, whatever one is on this side, the numbers are the smallest on the inside and they go to the largest on the outside, okay? So smallest to largest on the outside. Again, this one is expanded, not necessary, but it is expanded. What I want to do here, let's see here. Let's say I had, let's say instead of doing it this way, let's say we have the males here. So if you notice, again, they're sharing that stem there. So that's 0, 1, 2, 3, 4, 5. And the males, they go like this. So it looks like I've got 4, 5, 5. There's 3 5s. There's a 6, 4 7s, and an 8. And then we have 1, 2. Those guys don't have a lot of shoes. All right. So, and then we'd have the females over here. Okay, so these are my males here. So we had our females on the other side, and they look however they look. I just want to be clear here on describing these distributions. When we were looking at that female distribution, so this is the one that's not expanded. So essentially, this is what you would see over here. So when we were looking at that female side right there, and I look at that shape right there, we could say again the shape is maybe slightly skewed right. So maybe there's a little bit of a tail over there. When I look at the males here, yes, there's a little bit of a tail. So maybe you want to say that it's skewed left. But is that correct? Because if you look here, if you think about it, if I would put the males on this side, they still would have had most of their shoes here and not a lot down here. So they would have been skewed right. So whenever you're describing the shape, you want to describe the shape of both of them using that stem in the same direction. So if I'm looking at the females from 1 to 5 and I'm saying they're slightly skewed right, I have to think about looking at the males from 1 to 5. So it's almost like I'm looking at a mirror image of whatever's on this side. So if I had 1 to 5, then I would find that peak at 1 and it'd be coming down at 5. So again, it's also going to be skewed to the right. So you want to make sure that you're comparing them both with the stems going in the same direction. All right, these next ones right here, I don't really want to do all these next ones. I just want to show you some things about these next ones. So in this particular one here, you see that there's decimals. So one thing with the decimals, what you could do here, we could round obviously, but this one only has 1 decimal place. So why don't you just use your key to denote, before I go on, back up here, when you make the key for this one, well, let's use 1. So then what I would say here for that key, I'd say, so 0, 1, 3, so this means for males, and this is 10 for males, and then 10 for females. Sorry. Okay, back down here now. All right, again, so when you're making that stem and leaf plot, what you can do here, just use your key to denote where your decimal is. So what I did here in this one is I did 5. So like here's that 5.8. So instead of putting a decimal in there, I just said the key means that there's a decimal there. Okay, so you can always utilize your key there. Again, if you want more practice, you can feel free to do these examples. I'm just going to talk through them here. And this one, you can do a back-to-back one. So if I just straight up do the back-to-back one, this is what it looks like. There's my key there again, so I've got 13 and 14. I could add here 13 for economics, 14 for libertarianism. Again, you could do it as an expanded back-to-back. So again, you're still using that 0 to 4 and then 5 through 9 idea there. In the next data set, one thing you'll notice here about this one that they all share is that there's a 0 on the end of it. So you could just cut off the 0 and you could just denote that in your key. I don't like this one just because I have 2 long lines, so I prefer this one as an expanded one. It's not wrong here, it just looks prettier. I think I just have 2 long lines. The other thing you can do, so in this one we've got a decimal and we got 2 decimal places. You can always round things. So with this one we could round them to the 10th. Just make a note somewhere that you rounded to 10 and also then denote that in your key. So there's definitely things we can do, to kind of make our stem and leaf plot look a little pretty and as opposed to like kind of cramming everything in. Okay, so you're going to love me right now. You're definitely going to want to fast forward through this because I didn't type this data in advance. So histograms is our last type of graph. This is the most common one used for quantitative data. So I want to make a histogram here. The first thing I need to do, this is the IQ scores of 65th grade students chosen at random. what I want to do here is I want to type all these scores in there. So I'm going to go to Stat, Edit, and then I'm going to go to Enter. I'm going to clear my list here. I have some stuff in here. So I just use my left and right arrows to go through the lists. Use my up arrow to get up there. I hit clear. It's gone. Up arrow, clear. I'm just using the arrows to go back and forth, hitting clear. They're gone. All right, we want to type this data in here. So like I said, you might want to fast forward through this part or type it in on your own while you just watch me type them all in. See how fast it takes me. This will be interesting. Oops, that's wrong. Okay, now when I've done all that, what you want to do here is check your sum. So I'm going to go back to the main screen. So I hit second mode. I get back to that main screen here. I'm going to hit second. I hit the stat, which is below delete. I go over to math. I go down to number 5. Press enter. I hit second again, and then I hit number 1. So I tell the calculator I want you to sum up list 1. All right, if you notice here, I have a mistake because the sum of these values is supposed to be 6,899. So when I have a mistake, I go back in here and I try to figure out what the mistake is. So yes, it's kind of cumbersome, but I just kind of go through here and try to figure out what might I have typed in incorrectly, or did I leave something out? Right now I'm not finding it. Oh, right here. So I wrote 10 instead of 102. So literally you can just type it over. So I type over that. You can always use the delete button if you want to delete a value. So let's say I want to delete that 118, so now it's gone. And then if I want to go back in there, I can just insert. So I can hit second delete and then I get it back. All right, now let's see if I have the right thing here. All right, so now I have the right thing. All right, so to make this on the calculator, I'm going to go to second, y equals now. We are going to go over here to use the histogram graph where it says X list. Yours might be okay, mine's not. When I hit second, number 1, it's because I want the calculator to graph list 1. Frequency, leave that as blank. Leave that as 1. What it is, it's just a weighting. So it just tells the calculator how to weight things. So just leave it as 1. We just want things to be equally weighted. This is where you get to differentiate yourself. So pick whatever color suits your fancy. I'm always a pink person, but I'll refrain from pink. I'll stick with navy right now. All right, so then you can hit zoom, and it says zoom 9. You can just hit zoom and then hit the number 9, or you can scroll through. If you notice here, it says zoom stat. That's the stats. That's the zoom we like to use here in stat. All right, once you've done that there, what you'll notice here is if I try to hit trace right now, it tells me that in that particular bar, the values go from 81 to 90.142857. The next bar, it goes from 90.142857 to 99.285714. These numbers are really ugly. Like, I don't like this. I am not really pleased working with that. So I want to adjust the classes. So to adjust them, I'm going to go into my window. 81 is close to 80. I just don't like odd numbers. I'm going to switch it to 80. You could leave it as 81. So sometimes you want to change that minimum. The other thing you want to change is the X scale. The X scale is what's going to tell you what's going to space those bars. Always round up. So I'm going to round that up I'm not going to hit zoom 9 now because if I hit zoom 9, it's just going to default back to all these things. Now I'm going to hit graph. So now if I hit graph and I hit trace, you can see the first bar goes from 80 to 90 and there's 3. Then I've got 90 to 100 and there's 4. Okay. So then if you wanted to make this graph on paper, so again, not really, I'm letting you copy it directly from here. What I would do here, I'm not going to give you a scale right now, but like I would mark this as 80. I would mark this, I'm sorry, not going to give you labels. I'd mark that as 90. I'd mark that as 100. You know, this would be 110, and then, you know, so on and stuff. The tallest bar here is 17 when I scroll through using the trace. Again, that trace is right there next to the graph button. So, I don't know, so this, let's say 2, 4, this isn't going to fit 6. All right, so on. So my first bar goes up to 3. So then I would just make a bar here. My next bar goes up to 4. So again, I make a bar here. 14. All right, and then I would just keep doing that there. I'd just keep tracing it. All right, a couple things I want you to notice here that I'm doing. If you notice here in the histogram, it's not like a bar graph. In this one, the bars are touching. It is like a bar graph in the fact that the spacing here, however wide that bar is, I want to keep that bar, that spacing there, consistent, all right? The other thing, that width of those bars there, there's really not a good rule for me to give you. Like, the best guidance that I can give you is just follow that. Remember when we did that zoom 9, we looked at the window there. Sorry, it's still leaking. We see that X scale there. So again, the best guideline I can give you there is just to round up. If I make those too small, then my histogram's really spread out and it's not very meaningful to me. If I make it too big, my histogram's like all lumped together and it's not very meaningful to me. So to just kind of get that, using that ideal number right there, that's probably your best thing to do there. I feel like I messed something up. Oh, I didn't change that again. So you want to just make sure that you round that. You use the calculator's guidance. We can also do the socks here if we wanted to. Again, we're talking in general because we haven't calculated anything. So the shape, I'd say it's roughly symmetric. There's no outliers. The center, I'd say, is in that, the center is somewhere in that 110 to 120 range. And the values, I could actually calculate the range here. I think the values range from, the highest one was, actually, the highest one was 145. I feel like that's, the highest one is 145. The lowest one is 81. So then I could calculate the range, and I get 64. Okay, so we could do that as well. Okay. Here's one here. You can try this one on your own if you would like to. The data sums to 354, and this is what it ends up looking like. That's how I did it. I made it start at 1. I could have had it start at 0 here. I don't know. I guess I like the number 1 more than I like the number 81, and I also, maybe because it wasn't going up that high, I just figured I'd keep it as 1. So again, you can use relative frequencies on those. Either one is fine. I would definitely use relative frequencies if I was comparing distributions. So when is it preferable? If you're comparing two things, it's preferable probably to use the relative frequency. All right, and here's a set of practice problems for this note set.